Prithviraj Umesh, sir. Just to give an introduction to Dr. Prithviraj Umesh, he has completed his BE in Civil Engineering from NITK Surathkal, MTech in Structural Engineering from NITK Surathkal again, and PhD also from NITK Surathkal in wind engineering. Presently, he is working as an assistant professor and the virtual lab coordinator at NITK Surathkal. Sir has a lot of achievements to his credit. He has handled many research projects of MHRD and DRDO, and also from the Board of Research in Nuclear Sciences. And he has got a few honors and awards for his contributions. Some of them are he has achieved the best paper being a co-author in an international conference on ocean engineering in 2018 at IIT Madras, and he has been a faculty mentor for the top 5 projects in DRDO Golden Jubilee Students Competitions 2009, and also in also in NDRF Innovative Technology Contest at Conference on Leveraging Innovation for Knowledge Economy 2019 at Bangalore, and for that particular contest he was a faculty member again, faculty mentor, top 5 projects. And some of his other key achievements are he has handled many projects, around 24, spanning 25 crores, and number of journal publications he has 8, and total conference publications are 69, and product development projects mentored are around 19, and consultancy projects 6 worth 32 lakhs rupees. And he has been invited for technical talks to a number of 213, and his research interests are wave structure interactions, open source product development, wildlife conservation, and autonomous navigation systems. So I request Prithviraj sir to take over the session.
Yeah. Good afternoon to all of you, and we'll showcase how we try to give a virtual tour for our students and how they can be able to experience the lab and perform the experiments. So I am sharing one of the screen wherein which it showcases my portal, faculty portal, wherein which the classes that I handle and how it reaches the students. So this time we had to handle 7 labs. So let us take a simple example of fluid mechanics and fluid machine, which is common for civil engineering and mechanical engineering. Similarly, strength of materials or mechanics of solids. So I will start with a simple example and try to give the best to the students so that they can perform the same experiments remotely sitting at their location. So I'm accessing, this is a complete development done by the students group mentored by faculty, and it links to the Moodle. From here, I am trying to showcase the class within virtual tour. So suppose I'll just click onto a new tab. I'll share this tab over here, wherein which students can go and visualize and have an interaction to the which way they were supposed to do if they were in the lab. So this is the entry to the fluid machinery lab. So I'm just getting into it, and you can see all this, how it looks, and it's an interactive. They can use their phone and they can go into it, and they can able to see a detailed image if they want. They can click over here, try to get a detailed image of how the apparatus looks, what are those, how the film looks, all those things. So and they can rotate this 360 degree, and they can look down where they are, from where they are standing, and experience how the lab is in an NITK if they were supposed to do over here. So from there, they can move on to any one experiment which we are teaching. So it's all there in our portal. So let me show over here. So let's assume that we are doing, and here if you see, there is a simulations, there are some other tabs, there are some assignments that is uploaded over to method 1 and 2, and the experimenter. So I'll explain one by one. So let me go back over here. Now, if you see this, basically it's a complete 360-degree view, and the students will be able to visualize how big the venturi flume is, or a V notch is, and what if I stand on that steps and try to see what are these systems that are there to reduce the turbulence and make it as steady as possible, how the delivery wall is, where the hook gauge is placed, and all other things. Now, um, is that only the thing? So sometimes we need to show, because nowadays students have smartphone with them. So what we thought of, like, why not give them even more better facility? So for that, what we introduced was something like this, basically an virtual tour setup. Now, which they can do by themselves. There are two different versions over here. You can pin my webcam and see how the setup is. Basically, I can just unshare the screen. Uh, I'll just stop sharing it. So now here, you have this setup wherein which you can insert the mobile. Maybe you can go to the virtual tour of the links what we sent, and from there connect it over here, and then fold it and use it over here. And from here, you will be able to visualize the 360 feel as if you are into the lab, like a virtual reality. So they'll be able to access the lab, and they'll be able to trigger. So this is done by simple cardboard, something like a Google Lens, Google Card virtual reality kit, where we do lens, and you can use cardboard sheets and try to create a kind of setup. Suppose if you want slightly more steadier and other things, so we have also shared this laser template, wherein which they can use the cutting machines. We have a little more steadier, and you can activate that virtual tour over here, insert the phone and use the Velcro, and there is an elastic band over here, and you can put it onto the head, and then have experience of actually accessing the lab. So the main objective of doing this is basically students will be able to visualize how big the setup is, how big the venturi notch is, and otherwise only through simulation it might be slightly difficult for them to visualize. Of course, being a teacher, we would have seen the setup many times, but for a student it might be slightly difficult. And and there might be very simple. And suppose if you want to go to next level, you can use 3D printing facility. This is an FDM 3D printer done by using statuses, and you have a hinge, you have a locking systems, and we have placed this a convex lens. You can see over here there's an elastic. You can adjust this elastic bands, adjust your height, and similarly use this phone and then connect it over here. And the purpose serves the same, but the method in which we have done that is slightly different. Maybe from 3D printing, from paper cutting, from a cardboard box, or it can be an laser cut thing. Or suppose nowadays students may have these kind of ready-made devices. This is from the Samsung. You can see this device. You can insert the Samsung phone onto it. This is given by the Samsung company. Or else, if you want to go to an advanced level, there is something called as virtual reality headsets, which is from the company called Oculus, and the model is Oculus Rift. You can also go for HTC Live. So this is a much advanced level. There's a voice feedback and other things. Of course, not that every student can afford this right at their place. So that is why, to give them more experience from simple cardboard box or an carton box kind of things, or an little stiff glass, wherein which it can just be sufficient to hold their mobiles, they will be able to experience. Now, this was the thing that we did. so that they will be able to visualize the lab.